In this last video, I'm going to be going over polar to rectangular equations or rectangular to polar equations. And this is probably the most involved of all three of these videos that go over, you know, just polar coordinates in general. And this one, I really want you to be familiar with trigonometry, and we're also going to be throwing back to completing the square from algebra. And again, like I said before, this is really what makes polar coordinates so tricky, is because you have to be really strong with trig, and in addition to that, you also have to remember some old algebra rules that you may have forgotten. But I'll try to make this as painless as I possibly can. So let's first look at this one. Let's say we're given r is equal to 5 cosine of theta. And as you can see on the right hand side, I rewrote the formulas that we need to know just for this first example. So basically what we want to do is we want to get rid of all of the r's and all of the thetas, because we're going to be working, we want a rectangular equation, right? What we want is basically something in terms of x's and y's, not r's and thetas. R's and thetas are for polar coordinates, x's and y's are for rectangular coordinates or Cartesian coordinates. So what I want to do is I see a cosine theta in here. I see a cosine theta. When I do that, I really want to get this guy right here. I really want that over there, because then I can get my first x. So to do that, I'm going to multiply both sides of this by r. I'm going to multiply the right-hand side by r and the left-hand side by r. Because you can see that if I multiply the right-hand side by r, then I get 5r cosine theta. 5r cosine theta. And now you see that I have an r cosine theta in there now. I have an r cosine theta in there, which is going to turn into an x. But I can't multiply that just to the right-hand side for free, because what I do to one side, I also have to do to the other. So r squared is equal to 5r cosine theta. So I'm going to rewrite this, r squared, but now we see that r cosine theta, that's the same thing as x. Because look at this rule over here. It's the same thing as x. So this is just going to be r squared equals 5x. So now I still have an r in here, but now I look over to my list of equations and I think to myself, hey, is there anything out there that I can use to bail myself out of this, to get rid of that r? And the answer is yes. You see that if I look over here, this r squared, that's going to give me x squared plus y squared. So that's definitely something we're going to want to use here. So over here, instead of r squared, I'm going to write x squared plus y squared is equal to 5x. Easy enough. Now all we have to do is just get that 5x over and set it equal to 0. So x squared minus 5x plus y squared equals 0. And that is the rectangular equation of this, right? We only have x's and y's now. We only have x's and y's, no more r's and thetas. But normally what's going to happen is in books, especially in the Stewart calculus book, when you're working with polar coordinates again for calculus 2, is they're going to ask you to identify what this curve is or what this equation is. And they're going to want the proper form of it, because they're going to want to know, hey, what shape is this? What shape is this? And it's up to, we look at this and it's really not as obvious, but it's up to us to be able to make it in that form. So one thing that you should remember too is the equation of a circle. Remember, the equation of a circle is defined as x squared plus y squared is equal to r squared. That's a circle right there. That's just a circle. So in order to get this form, I can't have this negative 5x over there. I can't have that. So I want to get that. I just want an x minus something squared. So in order to do that, I'm going to do what's called completing the square. Completing the square. And if you're not familiar with that, remember that it's just b. It's just b. It's b over 2 squared. B over 2 squared. So it's just this middle term, this negative 5 over 2 squared, and I'm just going to get 25 over 4. So what I'm going to do is I get that b over 2 squared, which is just 25 over 4, and I'm just going to add it. Just going to add it over here, 25 over 4. But I can't do it for free. I got to add it to the right-hand side as well. So that 0 plus 25 over 4 is just 25 over 4. So all I did again was I recognized that I have an x squared and a y squared in here. I have an x squared and a y squared. Recognize that this is a circle, but I want this circle in a form where I can recognize what the center is and what the radius is. So in order to do that, I used completing the square from algebra 2, where I take the middle term, b, and divide it by 2 and square it. So I did negative 5 divided by 2 squared, and I got 25 fourths. Then what I did was I took that and I added it to the left-hand side, and then I realized, hey, I can't just do one thing to one side. I have to do it to both sides. So I added it to the right-hand side as well. So now what I want to do is I want to take that x part, that x portion, the x squared minus 5x plus 25 fourths, I want to factor this. And if you play around with this, you're going to find out that it factors, not foils, factors into x minus 5 halves squared. That y squared stays there because, x minus 5 halves squared, that's the same thing as writing that. Plus y squared is equal to 25 fourths. And we're done. This is a circle where I can identify the center and the radius. So the center in this case, the center is just 5 halves, comma 0. And the radius is simply just, this is the radius squared. Remember that this is the radius squared. So what squared gives me 25 fourths? Well, the answer is just 5 halves. 5 halves. So this is a circle with the center of it being 5 halves, comma 0, and the radius being 5 halves. So you can really appreciate the beauty of polar coordinates, right? Because look at this, look at this. This whole thing right here, this is a circle at that center, with this radius, this whole mess of an equation right here. And you can imagine how difficult that's going to be later on in calculus, to differentiate or integrate and things like that. It's going to be very tedious to work with. But then look over here. This whole mess down here was represented by just this single expression, r equals 5 cosine theta. Those two mean the same exact thing. And isn't r equals 5 cosine theta way easier to look at and way less intimidating than this thing down here? So it really helps you appreciate the beauty of polar coordinates and how much they can simplify things like circles or other odd curves. So again, I know I used a few techniques that we haven't covered or you might not have looked at in a while, remembering the equation of circle, completing the square. It's definitely something that you have to review and, watch this portion of the video a few times over again if you're not comfortable with it. But this was one of the trickiest ones for converting from polar to rectangular. But now we're just going to switch gears and go from rectangular to polar. I don't really feel the need for another example for this. It's really just, if you can do this one, you can basically do all of them. So let's just try another example where we're going to be going from rectangular to polar. Rectangular to polar. So if I want to go from rectangular to polar equation, then it's really just the same process. We just have to recognize when to use our formulas and so on and so forth. So let's say I was given x squared plus y squared equals 10x. Remember, I don't want to work with x's and y's anymore. I want this to be in thetas and r's. So remember that r squared is equal to x squared plus y squared. Look at your table of formulas if you have them written down. I can recognize that this over here is r squared. That's just r squared. So I'm going to write r squared is equal to 10x. And then I still have an x in there, and then we look, hey, is there any formula out there that will get rid of that x for me and give me a theta or something like that? Theta and r preferably. And the answer is yeah. If you look at back your list, you can see x is equal to r cosine theta. R cosine theta. So r squared is equal to 10r cosine theta. 10r cosine theta. And then what you're going to want to recognize is that when you're going from rectangular to polar equations, is that you always want it to be, r is equal to something in terms of theta, some expression with thetas in it. And you're always going to have r by itself on the left-hand side. It's kind of like when we had y is equal to some function, y equals 2x or y equals x squared. Same thing here, except we just have, r is equal to 10 theta or 10 cosine theta or blah, 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 blah. So in order to just get this final r by itself, I'm just going to divide both sides by r. So I don't have an r squared on the left. And I get r is equal to 10 cosine of theta. R is equal to 10 cosine theta. And that's it. That's the polar equation of this Cartesian one or this rectangular one. A really easy process, definitely easier than the last monstrosity we just did. But hopefully this one makes more sense. And really just, remember those formulas, So let's do one more example. This one was pretty short, and we'll just wrap it up from there. So again, let's go from rectangular to polar. I'll give you a more realistic one. Let's say we were given y is equal to 1 plus 3x. Okay? So we look at our list of equations. If you have them written down, I don't have them written down anymore. But I want to think, is there any way I can rewrite that r? Yeah, there is. Y is equal to r sine theta. And what about that x over there? That x is bugging me out. And yeah, x is equal to r cosine theta. X is equal to r cosine theta. So all I'm going to do is I'm just going to make some substitutions, where this r sine theta replaces him, that y, and this r cosine theta replaces that x. So I'm just going to make some quick substitutions. So I'm going to have, instead of y, I'm going to have r sine of theta is equal to 1 plus 3r cosine of theta. 3r cosine theta. Now remember what I said last time. I said you want it so that your thetas are on one side and your r is on the other side. Your r is alone. So what I'm going to do is I'm going to bring this guy over. I'm going to bring him over to get all of my r's on one side, to collect those terms. So r sine theta, and again, I'm just bringing this over, I'm subtracting it. So r sine theta is equal to, or r sine theta minus 3r cosine theta is equal to 1. Now all I have to do in order to get that r by itself is I'm just going to basically just factor out an r. I'm just going to factor out an r. So inside I'll be left with sine theta. Again, I'm just factoring out an r from the left-hand side. Sine theta minus 3 cosine theta. 3 cosine theta is equal to 1. Now, my last step, in order to get that r just all by itself, I'm going to divide both sides. By sine theta minus 3 cosine theta. So you can see that if I divide the left-hand side by this, it's going to cancel, but I also have to divide this 1 by that. I have to divide that 1 by sine theta minus 3 cosine theta. 3 cosine theta. There we go. Sorry about that. It's a little messy. And lastly, I'm just going to rewrite this all cleaned up and pretty. R is equal to 1 over sine of theta minus 3 cosine theta. And we're done. I have my r on one side and everything else on the other side. R is by itself. So this is the polar representation for that, rectangular equation. That y equals 1 plus 3x, that's going to be the same thing as r is equal to 1 over sine theta minus 3 cosine theta. So that's really all I have for you for this series of videos. I might go further in the future and work on graphing, cardioids or transversal circles, but this is really the basics of polar coordinates, and it's enough to get you through a pre-calculus class and a portion of the calculus 2 class where you go over this again. But hopefully these videos were able to help you out. Really just be comfortable with your trigonometry before tackling these guys, and be comfortable with, those basic algebra 2 things, or pre-calculus things, circles, completing the square, blah, 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 and be very good at your algebra in general. Hopefully these videos help though. If you have any other requests, feel free to message me. I'm always willing to make more videos for anyone who needs them from anything, any math topic ranging from just pre-algebra all the way until calculus 2. So any videos you have requests for, don't hesitate at all to message me, and I'm always more than happy to help. Thanks for watching.